going to look at question 4 from the week 3 tutorial questions. You're given two vector fields v and w, and you're asked to show that 3 div v plus 2d div w is equal to the divergence of 3v plus 2w. So the first thing we're going to do is we're going to calculate the divergence of v. So the divergence of v is going to be d by dx of x squared plus d by dy of xy plus d by dz of xz, which is equal to 2x plus x, which equals 4x. Similarly, the divergence of w, which is d by dx of x plus d by dy of y plus d by dz of e to the z, that's just going to be 2 plus e to the z. So that implies that 3 div of v plus 2 div of w is equal to 3 lots of 4x plus 2 lots of 2 plus e to the z, and in total that gives us 12x plus 4 plus 2 e to the z. Now we calculate 3v plus 2w, and that's equal to 3 x squared I plus xyj plus xzk plus 2 xi plus yj plus e to the zk. Collecting together all the like terms, we get 3x squared plus 2xi plus 3xy plus 2yj plus 3xz plus 2e to the z k. So hence the divergence of 3v plus 2w is equal to d by dx of 3x squared plus 2x plus d by dy of 3xy plus 2y plus d by dz of 3xz plus 2e to the z. And if we evaluate this, this gives us 6x plus 2 plus 3x plus 2 plus 3x plus 2 e to the z. So adding that all together, we've got 6 plus 3 plus 3, so that's 12x plus 4 plus 2 e to the z, which is exactly what we had before. We're now going to look at part 2. In this particular case, we're asked to prove the general version of the result we verified in part 1. So we select just two general vector fields, v, which has got components v1, v2, v3, and w, which has got components w1, w2, w3. We're going to start by constructing the vector field av plus bw. So that will be a lots of v1, v2, v3 plus b lots of w1, w2, w3, which gives me a v1 plus b w1, a v2 plus b w2, a v3 plus b w3. So that's giving us the vector field av plus bw. So now let's calculate the divergence of this new vector field. and this will be equal to d by dx of AV1 plus BW1 plus d by dy of AV2 plus BW2 plus d by dz of AV3 plus BW3. And now we can just use the normal rules of differentiation to split all the derivatives up. So for the first one, we get the following. So we get the derivative of each term with respect to x. For the second one, something similar happens. And exactly the same thing happens with the third term. Now that's using essentially the sum rule for differentiation. And now what we can do is we can pull the constants out the front. And we go through and do this for each individual term. And when we actually get to the end, we'll be able to again collect like terms and try and simplify what we have and hopefully get the result that we want. So that's given us this. So now we can collect together all the terms that involve an a. So we have that term, and that term. So that's a lots of dv1 by dx plus dv2 by dy plus dv3 by dz plus, and for the b terms we get dw1 by dx plus dw2 by dy plus dw3 by dz, which is equal to a div v plus d div w, which is exactly what we needed to show.